Hi everybody, in this video I'm going to go through our lesson on rhombus and square properties, and to get this lesson started I want to first focus on the parallelogram family tree, kind of our parallelogram hierarchy. So I hope you are familiar with our parallelograms and what they look like. So a parallelogram might look something like this. And our basic properties of a parallelogram, we know those opposite sides are parallel. So AB and CD are parallel, and BC and AD are parallel. Those opposite sides are also congruent. So AB and CD are congruent, and BC and AD are congruent. Opposite angles are also congruent. So angle ABC, that's like angle B, that is congruent to angle D, or angle ADC. We also know then that angle BAD, or angle A, is congruent to angle C, which would be angle BCD. So opposite angles are congruent. Opposite angles are also supplementary. So not opposite, sorry, consecutive. So if I add angle B and angle A together, the measure of angle ABC plus the measure of angle BAD, right? Angle B plus angle A is 180 degrees. Those angles are supplementary. Another property of parallelograms is that the diagonals bisect each other. So BD bisects AC to create two congruent halves, and AC bisects BD to create two congruent halves. The diagonals themselves are not congruent. And actually, technically, this would be 3 ticks, and this would need to be 4. So those are kind of separate from the lines. We already have congruent segments, right? So the diagonals bisect one another, and maybe I'll make this our middle point, M. So I can say then that AM is congruent to MC, and BM is congruent to MD because diagonals bisect each other. Now, a parallelogram, a shape can be just a parallelogram, or it can be more than that. It could be either a rectangle. Oh, is it going to do it? I'm sorry if you hear my cat. He really wants to be in here, but he lost his opportunity. It could be a rectangle, or a parallelogram could also be a rhombus. Get a little bit longer. Actually, let me color code this a little bit. So it could be a rectangle or a rhombus. So let's talk about the differences between those two shapes. And a rectangle, we already made a video, or I already made a video going over rectangles as well, as parallelograms we have a video for. And so I'm just going to draw kind of a diagram and talk about the features of a rectangle. So a rectangle looks something like this. Here's A, B, C, D. We know those opposite sides are parallel. The opposite sides are congruent. And all 4 angles are right angles. Also here in a rectangle, the diagonals are congruent. So I know that AC is congruent to BD, which means then that all of these little halves are the same. So that's a rectangle. In a rhombus, we don't have 4 right angles. Instead, we have 4 congruent sides. I'm gonna make that just a little bigger. So here is A, B, C, D. So we have 4 congruent sides. They are, opposite sides are still parallel, but now all 4 sides are congruent. Your opposite angles here are congruent. And your diagonals do bisect each other, but we're going to write down kind of the new properties that we have in a rhombus because diagonals in a rhombus, they bisect each other, but they also do some other things. And then a rhombus and a rectangle, if you have a shape that's both a rhombus and a rectangle, then that shape is a square. So these two shapes come together. Let's see how this looks. Not amazing, but that's okay. They come together to make a square. And in a square, we have all the features of a rectangle and a rhombus and all the parallelograms. So we have 4 right angles and all 4 sides are congruent. All 4 sides are the same. And then we have the features that are true of our diagonals. The diagonals are congruent. Oh, come on. And then what else we're going to talk about for rhombuses is true. So let's talk a little bit more about some special rhombus properties. And actually, I'm going to write this down below here. So we're going to dive a little bit deeper into what these unique properties are for a rhombus and a square. So obviously, rhombuses have all the properties of a parallelogram. What else is true about a rhombus? A rhombus has all 4 sides being congruent. So all 4 sides are congruent or the same. I'm going to draw an example here. This is, no, off to a bad start. I don't even know why I started it like that. Let's just kind of make it like I made my other one. That's not really a rhombus, but that's better. Maybe I can even expand it this way. Better. All right, so in this rhombus here, all 4 sides are congruent, which means AB is congruent to BC, is congruent to CD, is congruent to AD. All of those sides are congruent. Also, our diagonals, not only do they bisect each other because it's a parallelogram, but they bisect the opposite angles. So let's draw our diagonals here, BD and AC. So they bisect those opposite angles. So if we look at angle ABC, this angle B, and ADC, angle D, we know already that angle ABC is congruent to angle ADC, right? B is congruent to D as a whole in this shape because it's at least a parallelogram. But we also know that angle ABD, this small portion, this half of the angle is congruent to its opposite side. So angle ABD is congruent to angle DBC or CBD. On the other side, ADB is congruent to BDC. So I could say, my colors got a little bit funky here, but that's okay. Angle ADB, half of angle D is congruent to the other half, angle BDC. But then, of course, we know overall that these two angles themselves, angle B and angle D, are congruent. So kind of a lot of unique properties going on here. Oops, I didn't mean to undo all that. So the diagonals bisect the opposite angles and your diagonals are perpendicular. So I know then that AC is perpendicular to BD. So those are our rhombus properties. And then remember that a square is just a rhombus and rectangle combined. Special square properties. So in our squares, all four angles measure 90 degrees because they are all right angles. So this is because it's a rectangle. Also because it's a rectangle, so let's draw a square here. All of our angles are 90, and also because it's a rectangle, we know that our diagonals are congruent to one another. They are congruent, so BD, oh my gosh. BD is congruent to AC. I knew it wouldn't like it. I should always start from the bottom and go up. I think that goes better for me. They're congruent. They also are perpendicular. So they are congruent and perpendicular because, well, let's start with this. They're congruent because it's a rectangle. And then because it's a rhombus, the diagonals are perpendicular. Separating the reasoning. So the diagonals are perpendicular because a square is also a rhombus. So we know then that these are right angles formed. We also know that the diagonals bisect those opposite angles as well. All right, I am going to go through a couple examples now. So first problem, we are going to do the diagram first. So we are going to draw this rhombus, and let's see how it comes out for me. Not too shabby. This is A, B, C, D, and we have the diagonals, AC and DB. We know that AB is 60, and this ADB has a measure of 52 degrees. So that's stuff that's given to us, and given A, B, C, D is a rhombus. All right, so part A, we are going to find AD. And if it doesn't have the bar over the top, that means we really are asking what's the measure of AD. Right now, I know that AB is 60. So let's write that down. AB is 60, whatever the units are. And this is a rhombus. So all of our sides are congruent. So I'm going to say now that AB is congruent to AD because this is a rhombus, and that's a property of rhombuses, or rhombi, if you will. And then, since we know that they're congruent, I can say that AB has to also, or sorry, AD also has to be 60. So since AB is 60, AD also has to be 60. So that's the length of AD. Next, part B, we are going to find the measure of angle DEC. So, oops, I didn't label our middle point. This is point E. So that's kind of helpful here. We want to find DEC, so that has vertex E. So that is this angle here. And remember that ABCD is a rhombus. So I actually know then that lines AC and BD are perpendicular to one another. That's a property of being a rhombus. Rhombi, multiple rhombuses. Which means then that our measure of angle DEC, which is formed by those two perpendicular lines, that has to be 90 degrees because those two lines are perpendicular. All right. Part C, we are going to find now the measure of angle BDC. So we know ADB is 52 degrees. BDC is that other adjacent angle. So I actually can say the angle let's see, what is that? No. ADB, the angle we know, ADB is congruent to angle BDC, again, because that's a property of being a rhombus. We know that the diagonals bisect the opposite angles. So ADB has to be congruent to BDC. So I know then that ADB, that's 52 degrees. So that is our measure of angle BDC. All right, next example. Example 2, in rhombus LMNO, the measure of angle MNT is 6x plus 4 degrees, and the measure of angle ONT is 8x minus 8 degrees. Find the measure of angle OLM. And of course, we need our diagram for this. Ooh. Make it more rhombusy. It's not amazing. I realized. Okay. So LMNO, here is LMNO, and then T, as you might be able to figure out, is where the diagonals intersect one another. So let's kind of put together what we know, because we want to find OLM. So we want to find this angle here. We don't know what that angle is. We know that MNT, so here's M, here's N, here's T. We know that is 6x plus 4 degrees. And then ONT, oops, I need to do orange. ONT, this other angle adjacent to it, that is 8x minus 8 degrees. Now, since this is a rhombus, I actually know that the measure of angle MNT, or I could just say actually angle MNT is congruent to angle ONT. That's because the diagonals in a rhombus bisect the opposite angles. Diagonals bisect opposite angles. And that's in a rhombus, right? So I know then that those two angles have to be equal to one another. So let's figure out what that would be. So I'm gonna do this in gray. MNT is 6x plus 4, and that is equal to ONT 8x minus 8. So let's solve this for x. To solve here, I'm gonna move my x terms together by subtracting 6x from both sides. So I will end up with 4 is equal to 8x minus 6x is 2x, oops, plus 8, or sorry, minus 8. And then to remove that minus 8, I will have to add 8 to both sides to get 12 equal to 2x. And now I can solve even further for x by dividing both sides by 2. And this will tell us then that x is equal to 6. So how does this help us? Well, I know the measure of angle MNT is 6x plus 4 degrees. And now I know that x equals 6. So I'm going to let x equal 6. So this is 6 times 6 plus 4, which is really 36 plus 4, or 40 degrees. So the measure of angle MNT is 42 degrees, or sorry, 40 degrees. And that is helpful to us because I know then that that is equal to ONT. So MNT is 40 degrees. And then I know the measure of angle ONT has to be 40 degrees. And we can put those two together, right? So now I can say altogether this angle MNO that is equal to our two measures. That is equal to the measure of angle MNT plus the measure of angle ONT. And we know both of those angles are 40. So the measure of angle MNO, the entire angle, is 80. And really, I should write that out. It's 40 plus 40, which is 80 degrees. And this is very helpful to us because the problem asks us to find OLM. And we know that OLM is opposite MNO. So these two angles have to be congruent. So angle MNO is congruent to angle OLM. And that's just the properties of a parallelogram. So parallelogram properties tell us this, which means then that OLM, or the measure of angle OLM, is also 80 degrees. So we set those two angles equal to each other because it's a rhombus. So those two half angles had to be congruent. And then we added the measure of those two angles together to get the entire corner of that rhombus, the entire angle N, which is opposite angle L. So angle OLM is also 80 degrees. I'm going to make another video and I want to talk about a little bit with one example about squares. So please take a brain break and then watch that video.